Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Enol content depends on the stability of the enol form relative to the keto form. Key factors include 1. Aromaticity or conjugation stabilizing the enol, 2. Intramolecular hydrogen bonding, and 3. The acidity of the alpha hydrogens. More acidic alpha-ICH means easier enolization. Moving on to the next step. This is an alpha-beta unsaturated lactone with AC is equal to C double bond already present in the ring. The enol form of this compound would be the vinylogous conjugated form where the enol tautomer is stabilized by conjugation with both the C is equal to C bond and the carbonyl. The enol of compound 2 would be fully conjugated, aromatic like furanone system. Effectively, the enol tautomer here gives a hydroxyfuran to hydroxyfuran system which has significant aromatic stabilization. This makes the enol form exceptionally stable, so compound 2 has the highest enol content. Moving on to the next step. Cyclopentanone is a simple cyclic ketone. It has alpha CH2 groups on both sides of the carbonyl. The enol form is stabilized by the C is equal to C conjugation with the carbonyl. It is a typical ketone with moderate enol content. There is no extra stabilization from oxygen lone pairs in the ring or aromaticity, but the beta-keto-like situation does not apply here. Cyclopentanone has a typical enol content for a simple ketone higher than a simple lactone because the carbonyl of a ketone is less electrophilic, less stabilized than a lactone, meaning the keto form is less strongly favored compared to a lactone. In other words, alpha-ICH in a ketone is more acidic relative to ester lactone alpha-ICH, so ketones enolize more readily than esters lactones. And for the final step. This is a saturated 5-membered lactone. Lactones, cyclic esters, have their carbonyl stabilized by resonance donation from the ring oxygen, making the carbonyl less reactive and the alpha-CH less acidic compared to a ketone. Therefore, the enol content of gamma-butyrolactone is the lowest of the three. 2. Aromatic conjugated enol stabilization. I. Simple ketone, moderate enol. 3. Lactone, low enol content due to resonance stabilization of carbonyl by oxygen. Why other options fail? A. I to 3 is wrong because 2 has higher enol content than I due to aromatic stabilization. B. 3 to I is wrong, lactones have lower enol content than ketones. D. To 3I is wrong, 3. Lactone should have lower enol content than I, ketone. Therefore, the correct answer is C. Therefore, the correct answer is option C.